In this video, we're going to talk about chapter 7, which has some kind of mixed things in there. So we'll hit this just a little bit. So the first thing that it has are called enumerated types. Okay. And an enumerated type gives you the ability to, in essence, create your own data type. And it's used when you know that there are going to be very discrete values for something. Okay. So, like if you're writing a program, you need to know what year students were, like the student standing, whether it's a freshman or a sophomore or whatever. So, if you know that a particular variable is going to be restricted to just certain values, like freshman, sophomore, junior, senior, then you can use these enumerated types to avoid there being, lowercase j for junior, uppercase j, misspellings, all that stuff. So it's a way to enforce conformity. Okay. So the benefits of using an enumerated type. You have readability, so you're defining these constants that they always have to be one of those constants. Okay, these can have descriptive names. You have some type safety. You're only going to get, so you're when you ask the user for input, they're limited into what they can say. So you're able to control the type somewhat. Okay. It also can be helpful if you have to maintain the program. If you have to add another category or another item, you add it in one place and it takes place throughout the program. Okay. So I'm going to give you an example here. These are not, I don't think, the most useful thing that we're going to see. Um, these don't tend to come up a bunch, but it's worth at least hitting on, I think. Okay. So here's our normal program here. We use the keyword enum for enumeration, and then I'm going to give it a name. Okay. We can use a capital D here because this is not, it's in essence a constant. Nothing's going to change here. Okay. And then you just go ahead and put all of these things, Monday through Sunday in this case, all comma delimited. Okay. Um, you don't put it in quotes. That'll give you an error. You can't start with a number or punctuation or that. So it's got to be, the naming variable rules pretty much is what we're doing here. Okay. And then oddly enough, C++ does this a lot. At the end of the structure that we're creating, there's a semicolon. Okay. So once we've done this with days, then days becomes a data type. So I can say, where before I would say string today, I'm going to say days today. That's creating a variable of type days, the custom type we just created. Its value is equal to Tuesday. Okay. If I were to try to do this for Tuesday, it's going to give me an error. Okay. I can't do that. My only option is one of the predefined things that we have up there. Okay. So if you ask the user, what they're going to do, they can input a number, input a value, and then you can verify that they are picking something that's going to be correct. Okay. So what we often do, so these in essence are going to store an integer value. Okay. So a Monday would store a one or a zero, sorry. Tuesday would store a one and so forth, up to Sunday storing a six. So if you try to print these out normally, like I want to print out today, it's not going to work for us. Okay. It's just going to return an integer. Okay. In fact, we can go ahead and do that. So let's just go down to here. I'm going to see out today. Okay. And if I run that, compiling it first, of course, you see that it prints a one there. Okay. Which is not particularly useful for us. Okay. So again, Monday's a zero, Tuesday's a one. That's how that would work. Okay. So we don't tend to do that. So we're going to get rid of that. Okay. What we do instead, we tend to put it into a switch statement. Okay. We're going to switch on that today variable. And today will be either Monday or Tuesday. Do the rest of the days all the way down. And you have a default for an invalid day, but it really can't be an invalid day. Okay. Today only has these values. Okay. And that gives us the Monday and Tuesday that we could deal with that. Okay. So we may do a short homework problem in class on this. But again, when you need them, but it's not the most useful thing we're going to see. The book also talks about these anonymous variable things, and then it warns you against them. So let's just not even go there. Okay. There's no reason to create an anonymous. There's no reason for us now to create an anonymous data type. We're not going to do that. Okay. There's a discussion in this chapter about namespaces, which again, I don't think we need yet. So we'll come back and hit them later if we need to. But this chapter is throwing a lot of random stuff in there, which can be unfortunate. Okay. But something that really should have had its own chapter, I think, but didn't, is some string manipulations. Okay. So strings are very important in any language. Okay. So we've used strings already. Sorry, allergy season already. So I'm declaring a new string S here. It says hello there. Okay. And we haven't really done this yet, nor have we talked about data structures yet. But in essence, a string is a data structure. It's just a way of organizing things. Okay. So a string is just a sequential ordered collection of characters. Okay. This is the character H, and the character E, then the L, and then the character space, all that. Okay. So that's why we can think of that. So it's this linear structure. Okay. And in fact, we can get to each character in the string by using the brackets with a number. Okay. So with my hello there string, if I would say C out S square bracket, 0 square bracket, it's going to give me the H. And then so on down the line. Okay. In fact, as I've got here, we can go through this little loop. Okay. We can do the int I equals 0, I is less than 5, I plus plus. Okay. Then I'm going to go ahead and do first S0, S1, all the way to S5, which should get the hello. Okay. Which when we run that, we can see that. Okay. So in addition, there's a size function as part of strings, which returns how many elements are currently there. Okay. There's also a length function that does exactly the same thing. So size or length, either one works. Okay. There is a string library, which you sometimes have to include, but at least on our system, I didn't have to include it to get this stuff to work. So if it's telling you it can't find a function that you're sure you spelled right, if you're on a different system, especially, it's worth including the string library up at the top. Okay. So we can use this size function to make sure that we don't go beyond the length of our string. Okay. So in this case, again, we're doing our int I equals 0. Again, from the last video, I is a local variable only within the for loop, which I think is a good thing to do. You don't want loose variables running around as long as I is less than s dot size. Okay. So again, the size is going to be one bigger than the ending index since we start at 0. Okay. So when we do that, that's going to, and then I plus plus is going to take us through every one of those characters in the string that we've input. Okay. So one thing to watch for here is that unlike Python, where if you give it an index that's too big, it will return an index out of bounds error. C++ does not return an error. It doesn't work, but it's not predictable. Okay, so it's hard to say what's going to go on. When I ran this, at least earlier today, it just gave me a blank line or a blank space there. But don't do that. Make sure you're always checking to make sure that your index is within the valid range before you try to access it. Okay, and again, it's the size variable. The size -1 should be the biggest index value you can have. Okay, so a change from Python, strings are mutable, which means we can change the internal components of the strings. Okay. So for example, if I've got my S up there, which has hello there, the sixth position of that should be the T. So again, if I count over 0, 1, 2, 3, 4, 5, 6, let's say I want to make that a capital, then I can just directly say S sub 6. So the character located in that seventh position, indexed by 6, is now going to be equal to a capital T. Okay. Note these are chars, so I have to do a single quote, not a double. Double quote will give you an error. Okay. I can then print out that it's made that change. Okay. So there are lots of functions, string functions built in to C++. Okay. The book lists some of them in table 7.1 on page 496 and 497. Okay. And we're going to go through another example of using some of those, but there are certainly things such as clear. You can clear out a list. You can compare two string, or sorry, a list, a string. You can clear a string. You can see if it's empty or not. You can compare it. You can find it. Again, you can return the length. You can return the size. All those things. Okay. So let's look at a program that does that. Okay. Maybe I guess we could. I never compiled this one and ran it. So I'm going to do that. And there's where we're going up through the first five values. We're returning the size, which is the same as the length is 11. And that's where we're using that size in our loop to go through and do all of the values. And then these blank spaces in here, there's more this time than there were before, are where I'm trying to access an index out of bounds on my string. Okay. And then finally, the hello there, you see that what was a small t, I've changed that to a capital T. Okay. So the last thing I want to look at for strings is this program. This looks at some of those string functions. Okay. So I think the way to learn about strings, which is what we're going to do in class, is to just do programs that require you to figure out how these work. And for all these functions, it's you have to think about what is it that's being returned by the function. And you can look it up in the textbook, or you can go to cplus.com, has full listings of the string library and all the string functions. Okay. So that's how that should go. So in this one, I just have S1, S2, S3. I'm defining as empty strings. That's how we start. And I'm asking the user to enter a string. Okay. Then it's going to print out the length that they just entered, okay, of that string. Okay. Then I'm going to look at the compare. So we can already compare things, okay, with the double or the double equals. Okay. So the difference being, and I've got an example here. If we say we've got S2 is hello, S3 is there, they're not the same. Okay. If I say S2 equal S3, the equal is a relational operator. It returns a Boolean value, in this case, a false. Or the representation, when we try to print that out, would be a zero. Okay. That's all we get. We know they're not the same. Okay. On the other hand, the compare has more functionality. Okay. The compare will return a zero if they're equal. Okay. So we're the opposite. Where an equal would return a zero if they're not equal. The compare returns an equal, a zero if they are equal. Okay. But it also is going to give us a minus number, and the number doesn't seem to make a lot of difference that I can tell. So a minus if it's less than. Okay, so if S2 is less than S3, and the less than here is the lexicographic difference or the alphabetical, is it a lower alphabet number? Okay. Um, and return a positive if it's greater than. Okay. So we get a little bit more information. So in the way we would use that, we would say that S2 dot compare S3. Okay. So in this case, the H is less than or comes before T in the alphabet. So that should return a negative number of some sort. Okay. So then we get to the last thing we're going to talk about. And there are more functions even in the book, but we're just going to do some of these. And that's the find function. And the find function can be pretty useful. And we use find to see if there's an instance of a string inside of another string. Okay. So you've got a string, you're looking for some series of characters inside of the bigger string. Okay. So if it finds something, it's going to return the index position of where it found something. Okay. So I've got here S2 is equal to hello. So if I'm going to do a find on this LL, okay, it should return that it finds at the 0, 1, 2. The second position is where it starts. Okay. So let's do that one first and just see how that looks. Okay. If it doesn't find it, things get a little weird. Pilot, run it. Okay, doesn't matter. Well, this is going to give us something. So we'll just say today is Friday. Okay. So it's going to I've entered the string. It's going to give us a 5 here. Oh, that's interesting. Interesting, it gave us a 5. It gave us a 5, and that's something I hadn't thought about. But because I did a CN, it stops at the space. Remember, we need to use a get line if we want to get the whole thing. Okay. But in that case, we've got just the today. Okay. So we then have the size is the 5. Okay. And then it's checking here. I'm checking hello versus there, the two strings, returns a Boolean 0 or false. Okay. But in this case, it gives us the -12 here. Okay. Which means that hello is less than. Okay. And we'll talk about this big number in a minute, but this is where we're getting that result when we said, is LL inside of hello? And it is starting at the second index position or the third character. Okay. So this big number here, which varies by system, it's called the string : in pos. And it basically is the largest string possible somehow. So that's what it returns if it doesn't find something. Okay. So I just printed that number out there, but let me get rid of that and then we'll actually do a find where it doesn't find it. So that's what that big old number is going to look like. Okay. When I ran this at first, I'm like, what is this even doing? So this LCL is not found in the string. So if I run this now, okay, and enter whatever I enter there, okay, you'll see that it's going to print out this same giant big old number. Okay. So you could in your code say if the find returns this big number that you can get with the string : in pos, then not found. If not, it will return the actual index position of the first occurrence. Okay. So that's some basic things about strings. There's more things that we can do. There's an insert function. There's an erase function that gets rid of part of the string. There's an insert. There's a replace function. All kinds of stuff. So there are lots of things we can do with strings, and it turns out that strings are pretty useful. Okay, as a way to organize things. Okay. Um, Again, I think that the string tools in C++ are similar to what they were in Python, but not quite as handy. I think the Python string functions are a little bit better. Okay. So before class, I encourage you to go through some of the example programs in the book to look to see how this gets turned into practical code, because that's kind of the point. Okay. If you have questions, let me know.